Dear students, let's now study the center of mass of subtractive objects. Here, subtractive objects implies when from an object a part is cut, the remaining object is termed as a subtractive object. Like here we can see if this is a rectangular plate with the dimensions length L and breadth B, and in this if say 1/4 part is removed, then this 3/4 section of plate is left over, and this can be termed as a subtractive object, which is made from a rectangular plate by removing this 1/4 part. For this we can write this cut and remove. And for this section, if we just analyze an illustrative example, say we are given with a question that we are required to find center of mass of the uniform plate shown in figure if 1/4 of its part is cut and removed as shown. Now in this situation, if we are required to find the center of mass of this plate, here we can see there are 3/4 sections which is left over, and if we consider all the three sections are identical and are of masses m, m and m, then as these individual 1/4 sections are independent, their center of masses will be located at the geometric center. So if we just find out the position coordinates of the center of mass of individual parts, then for this part we can write its center of mass will be minus L by 4 and B by 4. For this section we can see its center of mass will be located at minus L by 4 minus B by 4, and for this section it will be L by 4 and minus B by 4. Now we know their center of masses, then we can directly find out the combined center of mass of these three sections, which is the center of mass of the object given to us. So here we can write center of mass of a remaining object is, that is after removal of 1/4 section, we can write xc. We know x coordinate of center of mass of a system can be written as m1 x1 plus m2 x2 and so on by summation of masses. So here we can write in numerator for this mass it is m into minus L by 4 plus for this also we write m into minus L by 4 plus for this section it will be m into L by 4 divided by, we are given with 3 masses is 3m. So here if we simplify it, these two gets cancelled out and the result we are getting is minus L by 12. Here masses also cancel. Now similarly we can find out the y coordinate of center of mass. For individual we can write m multiplied by, for this it is b by 4 plus for this also m into minus b by 4 plus this m multiplied by minus b by 4 divided by 3m. Here also these two gets cancelled out, masses will also cancel. So on simplifying we are getting the y coordinate of center of mass is minus b by 12. So here center of mass of this subtractive object we can write is located at minus L by 12 minus b by 12. That will be the answer to this problem. Let us take up another example for the subtractive object system. Here in this question it is saying, figure shows a uniform disk of radius r with center at C1, and from this disk a small disk of radius r by 2 is cut with center at C2 as shown, and we are required to find the distance of center of mass from C1 of the remaining part of the disk. That means from the complete disk, if this part is cut and removed, this section which I am shading, if this is cut and removed, the remaining part, for the remaining part we are required to find the center of mass. Certainly we can state when the disk was complete, its center of mass was located at C1. a part on its right side is removed, certainly center of mass will shift somehow to the left hand side, say by a distance x. So this will be the center of mass C0 of the remaining part of disk after cutting the smaller disk. So we are required to find the value of x. In this situation, we can directly use the concept of mass moments for localization of center of mass. Say for the complete disk, if it is of mass m, this mass will be distributed uniformly throughout its area. If we divide it in two parts, one is m1 and other is m2. m1 is the remaining part of disk and m2 is the smaller disk. And we can write m1 plus m2 will be m. Here m1 and m2 can be considered as masses proportional to the area of individual segments. So here m2 can be written as it is proportional to the area of the smaller disk which is cut and removed. So we can see the area will be pi into r by 2 square, this pi r square by 4. And we can see that throughout the area pi r square the mass m is distributed. So m2 can be written as m by 4. Similarly, we can calculate m1. m1 has to be equal to m minus m2 because total mass is m only. So m minus m2 can be written as 3m by 4. However, it can also be calculated by using the area. Now, if these are the two masses, we can consider the center of mass of m1 is located at C0 and center of mass of m2 is located at C2. Now, for both of these objects, the combined center of mass must be located at C1. That means for m1 and m2, combined center of mass is at C1. So, mass moment of this as well as this about C1 has to be equal to 0. So, we can write by property of mass moments, we use for this m2, center of mass is located at a distance r by 2, so its mass moment will be m2 into r by 2. And for this m1, it is located x behind, it can be written as minus m1 into x. This should be equal to 0. If we substitute the values of m2 and m1, here we can see we'll be getting m by 4 into r by 2 is equals to 3m by 4 into x. On solving, we'll get x is equals to this 4 gets cancelled out, m also gets cancelled out. It is r by 6, which is the answer to this question. We were willing to calculate the distance of remaining part of disk center of mass from C1.